So, hello. Let me talk about just a bit about me, more than David already told. So, yeah, I've been using Linux for about 15 years. Tried to use LFS. Who here knows what it is? Yeah. So it's basically Linux from scratch. You compile everything from the kernel all the way to the graphical user interface. It's very annoying to do, but I stuck with it for 2 years because, yeah, I had a EPC and performance was bad, and I said, yeah, let's have some fun and try to learn it. And then I came back to Ubuntu because I said, it's too much, and been using it ever since. Well, some friends of Ubuntu in this case. For the last 6 years, more or less, been a Linux grease monkey, so basically handling infrastructures and all kinds of problems and fixing things, and yeah, gets annoying sometimes, but it's fun. And fiddle with photography and 8-bits in general, so not just Sonic, but everything like retro computers, Commodore 64, and so on and so forth. If you want, you can send me an email. I don't usually use any other type of social networks. On GitHub, you can find me. It's more of a work-related account, but yeah, I do some other things from time to time. What I'm going to talk now. The idea of this talk is not to be a very technical one. It's more to show in the open source world, where I'm mainly trying to keep my profession, how open source can allow us to be secure and to prevent bad things to happen. Because most of the times what I see is that management or even developers come to us and say, yeah, look at this tool, it's amazing, but yeah, it's closed source, but yeah, it can do this or that, and we should use it. But most of the times, because they don't know that in terms of open source, there are alternatives, and good alternatives, and those alternatives actually allow us to build better control over our infrastructure and over our applications. It's somewhat focused on the top 10 from OWASP, but applied to infrastructure in this case. It's split into 3 pillars: securing your stuff, monitoring your stuff, and auditing your stuff. Why is that? Security starts from the beginning, ideally. So you should try to develop securely, not only the code that you're trying to run, but also how you implement your infrastructure. If you play fast and loose and just don't put the proper controls in place, then things will be much harder in the future. One good example, especially nowadays, with the advent of web apps, is having a web application firewall. Most of the places I've been don't really use it or use it poorly. And then it's up to us to either trying to figure out what happened or try to limit the damage that's going on. Luckily, it's a trend that's changing, but still a few things. So, how can you secure your infrastructure and your application in terms of what can you use in terms of open source? One of the top 10 things in OWASP is improper identity management, or poorly implemented authentication systems, or secret storage. A lot of tools can help you on that. As you can see, you have FIPA, Samba, which is great for replacing Active Directory, because those are a pain in the ass. And it's a good alternative to not only have a mixed environment, so you can have Windows authentication, Linux authentication, and so on and so forth, but also can store secrets for your application, because it also can replace a normal LDAP system. For other type of applications, you have other things. Syncope is a nice tool as well. It integrates a lot with web things. It's mainly identity manager, not as much as secret storage, but to prevent poorly configured authentication systems, Syncopy can help, because you can have a set of rules, a set of other things that can help. Vault is great as well. Secret storage, great to have key rotation, and so on and so forth. All the tools are, of course, open source. And just, it's nice to explore what the open source provides you, because you can then either extend, contribute back, or have great help from the community. One project that's I'm working on, we use Syncopy to integrate with it's basically a Drupal website. The integration was perfectly easy. We found out some modules that could help. We extended a bit. In about, I think it was about 1 month of development. We had a proof of concept. Everything was basically almost ready to go. We still have some kinks here or there to fix, but we're doing it, and it's nice. Another thing from the OWASP part is a network. Poorly configured networks can basically allow anyone to enter. One of the main issues is, for example, exposed services. We can see from Showdown, for example, if you search for IoT devices or MySQL ports or something like that, you'll find them on the world. Using these tools, you can somehow help you to understand what's going on and how you can secure it. For example, mod security is a great web application firewall, great for web apps. You install it on the entry point of your infrastructure. You set your rules, done. You have logging on it. You can have some sort of automation and learning of what is going on. And you can also extend, being open source, you can extend after something else without big hassles. Most of the other things are mainly, okay, can't see it, mainly network parts. So you can set up on the underlying system that you want to separate everything. And on a proper infrastructure, you split your backend from the front end, your load balancers, and so on and so forth, which most of the tools will recommend you to do. The extra thing here is the fail to ban, which it's a different type of software, but it's in a different category, which helps securing the network, but when you start to detect a threat at attacking your network. There are other tools which are not listed, but fail to ban is the most common one, and probably the most used one. Easiest as well, yes. You just say, and it's pre-configured with a lot of common things, like Apache logs, SSH, and so on and so forth. And it will just basically trigger NAT filter or IP tables to block that incoming IP. If you have other software like pfSense or OpenSense or other type of open source firewalls, you can have other tools, for example, Snort, which it's not securing itself. It's more on the auditing part, although it's not listed on my slides. But it will trigger back to pfSense or the other firewall to block the incoming traffic. Also open source, Snort, or what's the other one? Yeah, Suricata is another one. They are similar. And they do analysis on the network and see what type of behavior you're having, and if it's outside the box, it will block. One good example, it's not incoming but outgoing. Known bad IP addresses, bad protocols, for example, torrenting. If you find torrenting inside your network, Suricata will block it, or Snort will block it automatically. That's station or IP or whatever it is. Going another, so one above, so assuming that you installed everything properly, the next thing you want is to audit your infrastructure. So what can you do about auditing, and why is auditing important? You might be sure that what you implemented is good, but if you don't have any proof of it, how can you be sure, right? So the idea is you will simulate an attack on your infrastructure or your application and try to figure out if what you did is good, and if not, what are the key points that you should tackle first. And for that, it's a world of tools. The biggest, but yeah, I'll just basically one that's the father of all, which is Kali. Kali Linux is a great tool because it includes every tool that you need, from web auditing, pen testing, and so on and so forth. But Kali alone is not enough. You need to have other things on other sides. And focusing a bit on web apps and PHP in particular, for example, you have PHP CS, which is a coding standard tool, which it's here just to prove another point, which is you should audit always the code that you have running on your infrastructure, either in-house or if it's something else. It won't detect failures that are implemented in a good way, but since most of the failures are caused by poor programming or poor coding standards and missing some other things, having a tool that can audit standards on your codes is good. It will show you most likely places that can go wrong. And you, of course, need other tools to either do a stress test, which is another form of auditing. As you might have, we all been there, just someone came to you and says, yeah, but my application works great on my laptop. The thing is, when it's put on a big infrastructure, when it needs to scale and have some sort of load and so on and so forth, you'll see problems. And that's where CH comes from. But of course, way other tools, open source tools also exist, which the idea is you also stress what's going on, stress your infrastructure to see what's going on. One common thing is, for example, the database is not big enough for the load, and it will crawl to a halt, and then you have basically a denial of service on your application. To really know what's going on in terms of, again, infrastructure, audit is the best you can have. It will monitor everything on the operating system level, and report, depending on how you configure it, the amount of things that are going on. For example, SSH access on a different level, seeing what the user is running, commands ran, so on and so forth. This eventually plugs into the other pillar, which is monitoring. Monitoring is probably, I wouldn't say the most important of them all, but the second most important. Ideally, the most important is securing your things beforehand. But monitoring will definitely show you what's going wrong. If you are under attack, if you are having issues in your application, and so on and so forth, proper monitoring will tell you what's wrong. And for that, of course, we have also a great world of open source tools. I split this in two different categories because it's an important distinction to have between general monitoring, where you just monitor everything, and here you have great tools that implement this, like Prometheus and Zabbix and so on and so forth. Grafana is great to have pretty graphics to show management. They love it. And what is great among these tools is that you can, again, customize to your very particular needs. One thing on the place that I worked with, we did was with Zabbix, and we had our custom application that, of course, no one else supported. We even tried to check out for custom solutions, but they would require huge amounts of money to do what we needed. And we said, okay, it's no point in that. Just pick an open source tool. We developed in-house the modules that we need to plug it into it. Took about 2 months to have everything ready. We deployed. We monitored all the 300-something apps that we had running, or web apps that we were running. Huge amount of data, but yeah, it managed. And again, open source saved our days in monitoring. And we discovered a lot of things that were going wrong there, which was nice. And the other part of monitoring is logging and analysis. It's nice to have monitoring, but if you know how to correlate the things, you might fall into errors. One of the main important, or the main issues is people coming to you and say, yeah, but I saw this error here and I know what it is. And you spend hours trying to figure out where the error comes from. And then you see, okay, yeah, it was because that node in that particular time was down, for example. Another thing is, for example, if you are under attack and you don't know, you need the tool to do analysis on your logging on the fly, or more or less on the fly, to tell you, hey, something is going wrong here. And although you have good commercial tools that do this, if you have a different, for example, logging standard or a different way of doing your logging, then it might break. Which is where, for example, the authsim comes in. You tell it how your logging is and your patterns, and it will take logs, for example, from audit.d or the application and so on and so forth. And it has a database of known attacks, common known attacks, and it will alert you if that is bad. It will raise an alarm or even take some actions if you configure for doing so. And of course, AlkStack and FluentD will help you to correlate data between huge amounts of data and sources, which is also great to know what happened, when happened, and what was the proper root cause of it. Not just because the code broke or something else that you don't know, but point you to the right place. And this is basically everything I had to say. But feel free to ask questions if you have some.
How much time would you take to configure everything you just told in your presentation?
Everything?
Yeah.
How many people do you want to work on it?
Just you.
Just me. Okay. Let me go back and then we'll go through it all.
One of each, of course.
Yeah, of course. Okay, so here, for example. Here. Oops, sorry. For the secret management, 1 day, basically.
Okay, and you could tell in your personal use case, what would you choose and why and how much time?
I would. For example, for infrastructure authentication and secret management, I would choose Vault nowadays. It's very easy to set up. It's just a daemon that you launch. You point it to the right backend and it's there, up and running. If you want to set up a cluster, it takes a bit longer, but no more than 2 days. It's very easy to do. To integrate with authentication systems like SSH, it's not so easy, but OpenStack helps you on that if needed. FreeIPA, for example. I said OpenStack. Stack Exchange, sorry. Yeah. Yes, very much. No, Stack Exchange. That's this is true. Sorry, it's sort of true in the internet, right? FreeIPA, for example, would take me a week to do. It's a lot more complex in this case. but it grants you a bit more control over your infrastructure for logging and login and role management. For network, I can say for experience that the pfSense would take me 2 days to set up, deploy and configure almost everything that needed. And mod security, about 1 day as well. No, fail to ban is just 2 hours. Come on, it's just too easy. Yeah. For auditing, yeah, that is another pain. It's a totally different pain. Audit need to be properly configured. For example, it takes me a week at least to proper tune to every application that is there, the things that we want to log, and actually just figuring out what we want to audit. It takes a lot. Well, Kali is it's whenever it's needed, you just do it. For monitoring, well, I can't say an estimate on that because it can take from 2 days to 2 weeks, for example. It really depends on how weird your infrastructure is. Yeah, setting up alarms, it's a continuous job, pretty much. And yeah, setting up alarms, setting up everything to push or to monitor your applications, it can take a lot of time. If you just want to monitor the infrastructure, it's pretty easy. For example, for Zabbix, you just deploy the containers of Zabbix, which takes like 2 hours to deploy. And then you deploy the agents. Everything is auto-discovered. Yeah, you're ready to go. But then if you want to monitor something else, yeah. What?
Because then you basically don't use any encryption.
Yeah. But if you want something simple and fast, you can do it. But
I think it.
But of course, if you want to do proper things, it will take a bit longer.
I mean, I wrote some stuff about that. So it's
About
pretty easy if you slurp around like, doesn't it work? No, it doesn't work.
No, it's just to be recorded. Yeah, it's recorded.
In that case, I mean, it's something that I would like say should be rather properly done. So like estimating like with Zabbix setups and not doing encrypted, especially in cloud scenarios or multi-vendor scenarios where you distribute not within your own subnet of the data center.
Cross vendors and or cross infrastructures.
But it's true. Like the default setups helps you really get you going without like spending or like weeks in Prometheus doing everything custom from scratch.
Yeah. So that's why you can take for like a very short time to weeks, 2 or more weeks, depending even on the size of your infrastructure. Because you can be in a situation that you configure everything properly, but then you forgot something and you have to go back all the way to the beginning, which is very annoying. And for logging and analysis, it's another God knows how much time. Because again, deploying an elk stack is fairly easy, but then having things properly feeding it and doing analysis on it, it can take weeks. Really, really long time. But yeah, in 6 months you can have everything ready, let's say. If it's the only thing you do, if you are focused on these tools and just implementing.
If you don't have any fires to
Exactly. Basically, if you are dedicated to it, in 6 months you can implement open source tools. Which, in terms of if you do a return of investment, might be neck and neck with the proprietary solutions, but you have way more flexibility and knowledge of what's going on. Yeah. Long-term support, long-term cost savings, and so on and so forth. Yeah. So open source really helps here in these fields. No more questions?
Yeah. Like what kind of work scenarios are you involved with that one then?
Which one? Everything you mean? Or just?
No, like what is the typical scenario? Do you get contracted for that one from companies or?
Usually it's I would say project-based, but it's a project without end. So being a DevOps is, you go there, you try to figure out what's going on, you plan a scenario that you want to improve, and you work on it, basically. It's not like a consultant that you go there and just say, you just change this and go away. No. We really work on scene to improve the things and deploy everything.
And how long is the typical duration of projects then?
Well, for this type of things, people usually stay about 2 years, 2-3 years, and then change for different reasons. Because most of the time you want to try something new. When you are on a single place, you just keep with that technology, and of course, yeah, it gets boring after a while. Or the company has a different mindset, changes the mindset, and then you're sort of no longer needed, in a sense. As for example, they want to migrate to the cloud, or they want to change to a different thing, so on and so forth. Or yeah, or just subcontract to another company. That also can happen. Okay, no more questions? Okay, thank you all. Hope you liked it.